Hello again. So welcome to the second instalment of some brief videos to help introduce experienced programmers for Python. So as I mentioned in the introductory instalment, there's lots of ways you can run Python. So I'm just going to switch to showing you some ways of running Python. So here we go. So there are lots of tools and integrated development environments for Python, but I'm going to use Jupyter Notebook here for the example. So I'm going to use in a tutorial just because it's nice and easy to see, big fonts, but there's no implication that you should do that. But it's useful. So why am I talking about Python? Am I a Python specialist? Am I a Python expert? No, I don't tag myself as a Python specialist or a Python expert, but I am a programming languages expert, and what I do is look at the difference between programming languages, compare programming languages, very experienced on many programming languages, not just Python. So I'm in a good position to introduce it to people with experience in other languages because I'm well aware of how different Python would look, and that's the purpose of these videos. So I'm starting off with aiming at programmers with less experience that might just have done one language for a short period of time, but I don't know what that language is, so I've got to do this introduction based on viewers being aware of many different languages. So what do we see? Visually, and I'm looking at this example on the left that just happens to be in Emacs here. How does it look different to other languages? Well, one thing you can notice is there isn't many curly brackets. And we're not seeing some begin and ends. So you notice here I've tried writing a statement that might be how we might do it in an algol-like language, and we have an if statement and begin and end, and this language-aware integrated development environment has highlighted the if as a keyword, and so it's a keyword-based language, so we don't use different stroppings or case to indicate reserved words. They're all in lowercase, and if is a reserved word and begin and end are not. So maybe it's a C kind of language like C# or C++ or C, and we use curly braces, and no, it doesn't do that either. So the feature of Python that makes it different is its indentation that does it. So you notice when I do the if statement, it's indented. So we capture the indentation. Here if A equals B, I've got an indented statement, so it's because of the indentation it becomes part of that if. If I put a print statement here, it's not in the if statement. Okay, so indentation, you could say that's not common. There are a few languages where the indentation was significant, and for those who experience might go back a long way, if you can remember COBOL from IBM 360 mainframes from a long time ago, yes, that was one of the eras where we would have seen an indentation based structured language. So that's going to come as a surprise to some people, but it becomes quite natural after a while, particularly if your language aware editor handles it for you. But you can sometimes get into a mess, particularly with control flow. Okay, so we've seen the basics, and you see here I well, let's not make this A and B. Let's put 1 equals 1, so I've not got some variables. And one of the things I can do in my editor IDE is I can click the run button and I can run that piece of code, and I can run that piece of code, and I get equals and not in an if. And if I change that and run the code again, it doesn't say it's equal. So we can see the structure from the indentation, the control flow there. Okay, so that's some basic things that enables us to get going. So as you can see, there it has constants and it has operators like a regular language. Now you notice I did have A and B, and this is an interpreted language. What would happen if I haven't declared them? Well, I get a syntax error. A and B is not declared, but it says it's not defined. Python is an interesting language that there is no variable declarations. It's dynamically typed. And so I can just say A equals 0 and B is assigned 1, and then I can run the code and now it works. So it assigned the value and the type to the variable, and it got that from the type of the constant. So and I can just make these some different kind of constant, like a string, and that's correct. It's just retyped this variable as of string type. And I can try and do different kinds of comparison with these variables. So as you can see, assignments, expressions and constants look much the same as they do in most typical languages. I won't go into too much nitty-gritty detail because I don't need to. You're a programmer. You can go and find the manual and look up the more specific details that you need for your problem. I just need to capture the differences, and so done a nice little example of what an if statement looks like, and we can move on to some other things. So what about loops? Well, it has a while loop, so we could have while counter is less than, let's not go around too many, 4, and then we can print our counter, and we could do something like we can add up our counter and a sum, and then we need to do some initialization. We can set our counter to 0 and our sum to 0, which is just instantiated them, kind of like a declaration, and we could go round the loop. But let's make a programming error. Say I wanted to print the sum. I will have made a programmer's error here, and this is the typical kind of error where, well, look, it's gone on forever. Oh dear, I've made an infinite loop and I need to stop it. So what haven't I done? I haven't made counter equals counter plus 1. And we're still not happy with that. So I can interrupt the processor and run again. And so now I'm counting, but the mistake I've made is an indentation mistake, and I only want the sum at the end. So that's a kind of easily overlooked kind of programmer mistake that you get when you get confused by the indentation. So that's something for someone who's experienced in other languages to watch out for. There's going to be a similar problems with our if statement, because an else will go there. But if I hadn't cancelled that and I'd put the else there, again I would have made an error, and I ran and it's got invalid syntax because I've got an else that doesn't match an if because of the indentation. I have to match the indentation of the is and the else, and then it does compile and run because the indentation matches. So in other languages, although for beauty, for clean code, we would match the indentation, it's natural, but it's a syntax error in Python if we don't match the indentation, because it's indentation significant, and that's the importance of that. And as I said, we need to read the documentation. Go to python.org and click on documentation. Okay, let's go back to our examples. So if anything else you need in this area, you can look it up in the documentation yourself. So what have we got? It's got it dynamically typed. The type comes from the value. Okay, we haven't done some comments. So comments are pretty important. So let's so comments are done with a sharp. So we don't have C or C++ style comment / means something else. So this is a simple comment. And there is another kind of comment that we can have, which is a multi-line comment, which is done with 3 quotation marks. And then we can have this is a long comment used for documentation. Okay, so the 2 basic styles of commentary, and we've covered some basic control structures. We've got branching, choice, we've got iteration. The other kind of choice statement in many languages is switch case. That's a bit more complicated in Python, and I'm going to skip over that until I get to the later episode of advanced. Okay, so what else can we do? Loops. Why haven't I done a for loop? That's because for loops are a bit more complicated, and I'm going to cover those in a later exercise. But we're looking at while. You might ask, is there a repeat until? We can actually do that differently. We set up an infinite loop, and we can decrement the counter and we can do if counter less than or equal to 0. We can do a break. So let's print the counter so you can see it count down. 3, 2, 1, 0, and it jumps out at the end. So that's the stylized form of doing a repeat until. You can just make an infinite loop using the Boolean constant of true, and the capital T is important there. And yes, we got break, we've got continue. So it's meaningless, but I could put the continue statement, and there's a do nothing statement which is pass. So we've got various other things that we can do here. Okay, what other basic control structures do we need to know about? Oh, well, many languages have exception handling, and that's quite straightforward in Python as well, and it's try, as you'd expect. So try x equals x plus 1, and I can write something like that and see what happens, and it failed. Why did it fail? It failed because x is not declared. So some interesting things about Python, because it's an interpreted language, you can detect syntax faults at runtime, or some syntax faults at runtime. So that's another kind of flow control that you can do. There's another thing that you can put here, which is an else. So what that does is, if none of these exception handlers caught it, it goes to the else, which in some languages would be the finally clause. So that's syntactically correct. And so now you've got the else keyword can occur in both the if statement and the try except statement, which is a bit unusual. Okay, what else can we do? Some common things that we need. Another common thing that you quite often need is getting to the rich API library of modules and packages that Python offers. That's why another reason why Python is chosen, because it has a rich selection of these things. And I'll just import something from the system, and if sys dot we could look at the version. Something like that. Oh, I've got to put the colon, don't forget the colon. I am version . Let's have a go at that. Let's see how that runs. It doesn't run, so let's change that to not equals. So here we are. I can even at runtime find out what version of the Python system, and I could find out what operating system I'm running on, and so on, just by importing a system library. I can also import an operating system library and get at operating system functions. Some typical things that you want to do. So that's pretty much what we need to do in this very first basic installment, and I shall continue now. That enables you to get programming, do a few jobs, a lot of what you would want to do in Python. I'm going to look further at the type system and structured types and various other things in the next installment. So I hope you found that very useful for a quick introduction for somebody who knows how to program but just wants to know how do I write that quickly in Python. All right, thanks very much, and we'll stop there.